Hello and welcome to Code Rage. My name is Robert Love, and today's session is called Rock Solid and Secure Communications. Honestly, I didn't come up with this title, but the goal of this session is to teach you a little bit about SSL and how you can use it to encrypt your communications in a safe way for all the various products that are out there that Delphi supports, such as EMS, DataSnap, REST web services, raw sockets, etc. And so with that, we are going to go into a little outline. We're going to talk a little bit about SSL and how it works as a protocol. Really not how it works, but more along the lines of what options might you need to choose within it. Then we'll talk about some OpenSSL and how certificates can work with OpenSSL. We're going to talk about SSL with Indy, and then we're going to talk about SSL with IIS, and then we're also going to talk about Icehappy configuration, because getting that wrong can also give you you'll have security issues there as well. And so it's important to note those things, and let's move right along. SSL, or TLS, has several different versions of the protocol. One thing you should note is sometimes, quite often, SSL is referred to even TLS, even though, so they become somewhat as synonyms. But the version number and the actual protocol names are slightly different. So initially we had SSL 1.0, never was released to the public because it was found to be vulnerable to attack. So ultimately, they came out with SSL 2.0, and as you can see, it's now vulnerable to attack, and is so vulnerable that you should never use it. And SSL 3.0 recently was, within about a year, was exploitable by Poodle, and it is also recommended not to be used. TLS 1.0 and 1.1, a little less than a year ago, were found to be also exploitable by Poodle. And Poodle is basically a downgrade attack. It basically says, hey, well, there's lots of different aspects of Poodle, but one of the things that Poodle does rely on is says, hey, we have a problem with this various protocol, and we, during connection, let's downgrade to a prior version because maybe the server or the client doesn't support it. Well, with that, there has been a new option that the client can send that's TLS fallback SC/SV, and that basically prevents the client from downgrading. Another option is to just not have your server enabled all of those options. So you could say, hey, with this server, I'm only going to use TLS 1.2. And in the OpenSSL example that I'm going to show in a second, that's exactly what I've done. I also wanted to point out that TLS 1.3 was just barely introduced as a draft standard. There's no, there's lots of negotiation and things that have to happen, and testing that will happen before that becomes an actual standard. But I wanted to point out that it's ever changing, and that you need to stay up on top of security, and that once you've implemented it does not mean that it stays secure, because there are new and interesting ways that people are always trying to exploit this. So with that, let's talk a little bit about what it depends on. Well, it depends on a certificate on the server. And it also depends on a key, that the server having a private key. And it also depends, although this is a little bit more implementation specific, on having access to the certificate authority's root certificate. This is to verify the authenticity of the server certificate. And you can also use client side certificates in SSL or TLS. And this is something I'm not going to cover today, but it is an option. It becomes a little bit more difficult to maintain because you have to control both sides of the equation, but it is very possible to do and very practical when you're in an enterprise environment and you need to control and secure 2 endpoints and verify that those 2 endpoints are truly who they are. So with Indy and OpenSSL, there are 2 DLLs here, you can see them listed, that are required for server or client side. So we have lib EA 32 DLL and SSL EA Y 32 DLL. So regardless of whether or not you're using building a client or a server or both, you'll need these DLLs to ship with your code. There are also versions of these that will go with the various mobile platforms, and so that's just an FYI. You can deal with that. They're not just strictly, it's a library. It's not just strictly a DLL. Servers require 3 specific files. When we're setting them up, we need the root certificate, the server's private key, and the server certificate. And although I've said it before, it's important to follow the software that you use, the security software. So in this case, OpenSSL, and update it when security issues are found. OpenSSL has had vulnerabilities, as is many other software packages. Windows, Mac OS X, Android, iOS, they've all had security vulnerabilities within them. And at any given time, there are published ones that are existing. So patching and making sure you're up to date is very important at all times. So let's talk a little bit about a self-signed certificate in OpenSSL. Why do we do that? Well, for one, it's a nice thing for development. It's easy to do in development. Another thing is, if you're in an enterprise environment, you might set up your own certificate authority. Or maybe, when I mean enterprise, really what I mean is you're building software that's in-house, that's never going to be consumed by the general public. So my enterprise could be 2 machines. Really, it doesn't matter. But with the security certificate authority, that has to be known to all the people who will consume you. So it's not or consume your service. And because of that, it doesn't scale to the public internet. And with that, you can purchase certificates to allow that to happen. And so that's just a general thought to consider here as you're going through this. So let's, when we go through and build an SSL self-signed certificate, these are the steps that we kind of go through. First, we generate a private key. And after that, we use that private key to generate a certificate for that, the root certificate there. Then we generate a private key, and that's the server's private key. And that does not depend upon the certificate authority at all. And the server then sets up a certificate request. And the certificate request also does not depend on the certificate authority. At that point, with that certificate request, you can send that to the person who is running your certificate authority. So either the commercial entity that's doing it, or in your case of the self-sign, we will sign it ourselves. So with that, the server certificate is signed by that authority. And there are commands in OpenSSL to do all of those things. And let's go and show you how to do that right now. All right, so I've created a command file or a batch file that basically I call recreate keys, and it's going to walk through all the commands. I'm going to give access to this in the config file that it uses at the end of the session, and then you can use that as an example on doing the various commands, or just use it directly. And it'll hopefully simplify your life, because learning these commands can be a bit tedious. So we're going to say, do we want to recreate the keys? And this is great the first time, but be careful, you're creating the certificate authorities key as well, and you may not want the certificate authorities key to be deleted the second time around. So with that, you'll need to modify the script if you want to generate additional keys. that are based on that same certificate authority. So in this case, I say yes because I do want to delete those, and it'll delete the old files if it can find them and go on. Now there's some instructions that come on the screen at any time, but what I want to point out is this open SSL command, which is gen RSA. So open SSL gen RSA dash DES3 dash out, and then I pass a file name. And in this case, I'm calling it CA for the certificate authority .key .pem. And then I'm going to give it a key size. And so in this, it's 4096. I have to enter a password for this. So I'm going to enter that password. And then with that, it's a new password. So I just gave it that. Now I'm getting we're creating that certificate request. So, or not certificate request, we're creating the certificate for the root certificate. So you'll see this OpenSL request. And what will happen here is we just enter that password for the private key. And this is going to start asking some questions. And I'm just going to enter through these because it really doesn't matter for a developer certificate. I tend to put CA as the common name here and leave everything blank. At that point, we now have the need to create a private key for the server. So this is typically a different password than what the server has, so or what the certificate authority had. So we entered that in, and the other thing that should be noted is the key size is 2048 instead. With that, we get to create a certificate or request. So we need to do that, and we're going to enter the password for certificate request. And note that you need to make sure the country name is the same as the original request, or that won't work. And so we go through and specify each of these. The common name here is localhost, and I leave this blank. And now, with all of that, I now need to take the root certificate that I had and use it to sign the certificate request that we just created. And now it's requesting the password that we first gave. So there's two passwords, the one for certificate authority and one for the server. And we're asking right now for the one for the certificate authority. And with that, it's going to say, hey, this all looks good. Do you want to sign the certificate? And I can say yes. And one out of certificate requests created. Do you want to commit? And I could say yes. And the database was updated. And ultimately, if I now do a directory in this file, I will see a whole series of files. I'll see localhost, PEM, and I'll see the certificate PEM. The certificate authority key is highly secure. You should not distribute that, nor should you distribute the server's private key, except for in the place of, it should be on the actual server where the application is running. But the certificate authority key does not need to be anywhere near anything that you've ever done. And that's important. A bunch of files are created because it is a certificate authority that keeps the serial and the indexers that are used to keep track of future certificate requests. And so I just kind of keep all of that in mind. I know that's really fast, so hopefully you'll be able to go through the command file and look at each individual command. But it's an easy way to get this to work, and we'll go from there. Let's now go look at using this with Indy. All right, so what I have here is an Indy project that I've created. It's just a simple demo project, and it has both the client and server built into it. And you could keep them separate, but just for simplicity and navigation in the demo, I've put them together. TD, I started off by dropping down an ID TCP server component, and that's this component right here. and then I drop down an ID server IO handler SSL open SSL component. I also drop down an ID TCP client and an ID SSL IO handler socket open SSL component. And that's some big names there. But ultimately, there's a different handler that's specific to the server, and there's a different handler that's specific to the client. I've done nothing in the object inspector to these components. And the reason I did that is so that we could see it in code and understand it a little better, and make sure that we didn't miss anything. So with that, the button click that I have here to set up the server, we start off with the SSL options, and we need those 3 files that we just produced. So we have a localhost cert, which is the host, the cert file that we've generated, and the localhost key. And now that key is password protected, and so we'll need to supply that here in just a second. And the root certificate file is there. We also need to set the mode to server. And then we set the verify mode, and this is where we can say whether or not we want client certificates and verifying certain things as far as those certificate values. But we're setting it to blank and 0 because we have self-signed certificate, and we're not trying to verify any of that or use client-side certificates. On the SSL version, however, we're using SSL TLS version 1.2. And so you can see that here. And then you can see the on-get password. If I look at that, it's just a method that says the password. And note, I've put in here in real world, you should never use a hard-coded password because you'd have to deal with it every time the cert changes. And like the cert that we're using now expires in a year. That would be a pain to deal with every time. So this needs to be separate as well. Another thing to deal with is on the TCP server itself, we have to tell it what port it's going to listen to. And so with that, I've specified the server port. That's just a constant above of a number. And then we have the TCP server is finally set up an IO handler, and that's pointing to the one we just set up above. With all ID TCP servers, we have to implement an on-execute event. And so with that, there's the server execute. And we'll just show you what that code is. Here, we say, hey, we're going to go out with the IO handler and write out, hey, welcome to the Echo server. And then while connected, it's just a local value here. We are going to keep looping. And we'll read a value, and when we get the results of that value back, we'll write it back out to them. And so basically, it's just echoing the commands that came in. And with that, we can move to the client side of the server. So we're just going to go in and look at this client side. If you're using signed certificates, you're going to, that are not self-signed, you're going to want to change the verify mode and depth. But just an FYI there. But in this case, we're not, so we're just leaving them blank. We also set this to TLS 1.2, and in this case, we really do want the SSL mode to be unassigned. With that, we're going to communicate to the local host. So I've hard-coded the local IP address and the server port, set a read timeout, although it's not really required, and we then set up that IO handler that we've had, and we call connect, and we read that result, that welcome message back. So with that, let's just run this. So if I click the setup server, and then I click the setup client, you'll now see that we're now connected to the Echo server, and I can say, hello, code rage X, and hit send, and you'll see the results of that. With that, it's simple, but how do I know that I truly was set up right? How do I know that? Well, we're going to need to use some verification methods with OpenSSL. Okay, so what I'm going to do is just open up a command prompt here. and we're going to type in open SSL space s_client space -connect, and then we're going to specify our local IP address :6050. And with that, I get a connection, and I'm able to look at all of the results. I can see that it got connected. I could see that it's a self-signed certificate in the certificate chain. That's fine. I actually get to see that certificate. I know that it was read. I can also see that TLS version 1.2 is the negotiated protocol, and the cipher suite, which is the underlying encryption that it will be using, is AES 256. With that, I now have my echo server. So I can come in here and also type in hello code rage X, and it will return that result, and then I can quit as well. So that basically shows a quick way to test. And this is really a nice way to make sure that when you're doing this, there's a lot of headache that gets involved with making sure that your client or your server is set up correctly. And having a tool like this is really useful to verify that the connection is set up correctly and it's not your code. That the server's working, because when you're dealing with client and server, I could have problems with the client code, or I could have problems with the server code, and this is a way to isolate that very quickly. There is also an s_server command, and you can also have it respond as a HTTP server, which is a quick way to test your client code. And at least see that, hey, I'm getting connected. Whether or not it'll actually communicate with the protocol that you're after is another story, but it at least does allow some isolation that way. Okay, so we've covered how to host something under Indy and deal with SSL there. Let's talk about how we can do it also under IIS. Under IIS, you have to start off by disabling some older protocols and cipher suites. This is important to make sure that it's secure, but you also don't want to be so limiting that you can't, you prevent a lot of clients, because you are dealing with now a web situation. And so we'll deal with that here in a second. We're also going to talk about how to create a self-signed certificate using the Windows tools. You can also still create a PFX file from OpenSSL and import it in as well into IIS, but there's a little button that does it all for you, and so we'll show you that. And then we're going to talk a little bit about how to install an Icehappy DLL into IIS correctly. EMS, REST, DataSnap, SOAP, Web Broker, Intraweb, most of all of Delphi's web solutions involve an option to produce an Icehappy DLL, and with that, or one's already produced for you. Anyway, with that information, the cool thing is once we show you how to do one, you'll be able to do them all. And let's move right on to how to disable the older protocols. Well, for one, it can be done through the registry, and there are plenty of articles out there on how to do that. But there's a lot of options there. Unlike your normal simple registry entry, getting the cipher suites correct and getting all the options right, the odds of getting it perfect are really hard. It's just going to be a little tedious. So what I would recommend is using a tool called IIS Crypto. It's a free tool that's out there. You run it. Quite often you click best practices and then change anything that you need there and apply it. And you will have to reboot when you're done. But it allows you to just select which protocols you want and what you need enabled and what you don't want enabled, and go from there. So let's go into IIS or the Internet Information Services Manager. And from that, if I click on my dev box up here, or your first node in that, there'll be a link to server certificates. And all you have to do here is, now you're here, you can create a self-signed certificate. So to create a self-signed certificate is as simple as giving it a name. So let's just call this code Rage X. All right. And I have a self-signed certificate for my given machine. And now we need to choose to use it because the server has any number of certificates. So the default website that I have here, which is, we can have any number of websites, but the default one, let's just choose to set it up. So the first thing that we need to do is let's go over to this bindings, and we're going to select add, and from there we're going to select HTTPS and select that certificate that we just created. And with that, we can close it down, but the problem is now you can hit it via HTTP as well. And say we really want to ensure that this site is not accessible via HTTP. Well, we can remove that here. And another thing that we should do is in the SSL settings, we should require SSL. Now, requiring SSL will give a 403 error if somebody requests this site now without using SSL. Basically, like I said, SSL and TLS are synonyms in this respect. Really, it's us doing that. So let's quickly drop down. Let's just clear this. And let's just use the OpenSSL S client connect. And then this time we're going to have our local IP address and hit 443. With that, lots of information, certificate, etc. is there, but you can see towards the bottom I've got my mouse cursor running around it. It's using TLS 1.2 and a variant of the Diffie-Hellman algorithm with AES 256 and a SHA-384 hash. And so that kind of gives you some ideas of how it does. So I can just type get space / and I will have got the first page, the HTML from that server returned to me. So let's show doing the same thing in Chrome. Now, with Chrome and most all the browsers, you're going to have a problem because the connection is not private. And basically it's saying, hey, the reason this isn't private is because it's not from a certificate that we know about. And that is the problem with the self-signed certificate. However, this can be worked around and it's okay for on a development machine, but it's not something you can obviously have your customers doing. So pay for a certificate if you're publishing this. So I have a certificate. I'm just going to copy and paste this machine name right now. Copy. But if I go in here and proceed, I now see the IIS host. And with that, I can click up here and say certificate information. I can then click on the details. I can copy it out to a file. And in this case, I just leave it as the cert right there. Let's just put it in the keys directory that I was in before. Now that I've done that, I should be able to come in here and run type cert manager.msc. This will launch the certificate manager. I can come into the trusted root, and here's the list of security certs that I have on my machine. I can import up here and just choose that same the IIS cert, and it's going to place it in the trusted root authorities. And then the problem we're going to run into is if we come back to this, it will always have a problem. So if we paste our full machine name, now it actually recognizes that machine name. And so that was stored in the certificate during the self-signing process. So that in general is how to get SSL. It's pretty simple. Set up an IIS, and now let's talk a little bit about getting an Icehappy DLL. First off, to get an Icehappy DLL loaded, you're going to need to make sure that the Icehappy extension is enabled. So I've gone into the control panel, programs and features, and turn Windows features on or off, and that's what we are on right now on this dialog. If I come into IIS and then go under Worldwide Services and Application Development Features, I need to select Icehappy extensions. And with that, I can hit OK. And it'll take a few minutes, but ultimately we'll have that feature enabled and able to deal with Icehappy. So now that you have an Icehappy DLL, you could add it from various different sources. Like I said, EMS, DataSnap, a REST interface, a SOAP interface. Once you have an Icehappy DLL, you place that into any directory. You want to make sure that that directory does not contain additional information that could be downloadable from the thing. So we don't just point it to a directory that might have additional data such as DCUs, debug information. All that information could be potentially useful to someone if you're able to download that. So the first thing we need to do is we place it in that directory. With that, we go to the website and we right click and add a virtual directory. And in this case, I'm just going to call demo and the C and I just put this on my Icehappy path. So if we're there, we've just created a directory for Icehappy. With that, since we already installed the Icehappy extension module, we need to go up to the main site, or actually on the website here, and choose handler mappings. And with that, we get Icehappy DLL. All right, and with that, we get to choose if we want to edit its feature permissions over here on the right, or we want to select execute. And now that is enabled, but it is not enabled for every specific Icehappy. So you have to now go back up to the main server, and there's an Icehappy and CGI extensions. Those are configured at the server level. From here, I get to add, and I just specify the path to that, and I can just say code rage X, and then I say allow extension path to execute. And then I just say OK. And now that I've got that, I should be able to go test it. So we're just going to launch Chrome here, and I have the DLL already loaded, and you can see this. In this case, I had created a SOAP interface, and we're able to see the various endpoints that are there. Basically a simple way of getting there, but if you don't know those few steps, you can try a lot of different things. Now let's talk a little bit about securing this. All right, so what I've done is in that Icehappy DLL directory, I've created 4 different files. I've created a config.ini, a config.txt, a config.xml, and something called settings.config. All of these are just little sample files. If we look in config ini, you'll just see it says the word testing in it. And there's nothing special about these files other than we want to try to download them. And the reason for that is we have Icehappy DLLs, but if we're not careful, we could expose our settings via the ability to download. So if we go into the demo here and I type in one of these examples, so let's just do config.txt, you'll notice it says testing because that is actually a file that I have. The TXT files can be downloaded from the website. XML files also, you'll see testing. If I do config, however, ini, I'm going to get a 404 error, and that's expected. And we'll show you how that's set up and why. And then also if we come in here and do settings.config, it also gives us a 404 error. And why are those different? Why is text and XML? Well, by default, ini and config files are not set up to be downloadable. However, that doesn't prevent people from creating configuration files that are not with those names. And if that's the case, you need to do special settings in IIS. That's controlled through the MIME types. And basically, if there is a MIME type for the given file that you're trying to download, it could be potentially downloaded. So notice DLL is present, but if you'll notice, config is not. And if we come down here, ini is not. Okay, so config and ini are not there. But since your DLL is present that way, it is possible that you could set up your settings wrong on your site. So one of the things that I quite often recommend doing is, in case somebody makes a mistake and does not allow your Icehappy DLL starts getting downloaded instead, to be honest, I would prefer a 404 error. I like to remove the DLL from the default website and the DLL config, and those are no longer downloadable, so that this they can no longer get those. But granted, say you were distributing some code and you wanted a DLL and you wanted to put it up for download, you obviously need to deal with that. So those are some thoughts on securing and making sure that the MIME types manage with what you're after. All right, thank you for listening to my session today. The additional information that you might be interested in is the OpenSSL that I needed. You need to download the binaries for OpenSSL to use those. You also have the Fulgum Indy download for just the DLLs that are required are also on this link for the OpenSSL binary. We also have IIS Crypto, which I mentioned during the session, and then all the files and information from this session can be found on my blog, and here are the URLs. If you're listening live, I'd like to turn the time over to questions, and thank you so much for your time.
Ilya's asking, do you recommend RSA key length higher than 2048, or is 2048 enough for everyone?
2048 for a server is definitely fine. For a certificate 40, I'd go plug it at 4096. The speed that it takes to deal with 4096 is just not there on some hardware, and it's not wise.
Okay. Let's see. Can you include some Apache security thoughts in your session download? Alan's asking.
Apache security?
Maybe Apache server security thoughts? Is that what he's...
Yeah. The answer is I'm not familiar with Apache.
You don't use Apache server? What do you, IIS?
We do.
Linux?
But I have a sysadmin that deals with everything.
Oh, okay. Okay.
And if we're building C++ or Delphi apps, we're dealing with Icehappy.
Yep. Yeah, I know Marco did a skill sprint earlier this year showing how you could use Apache modules and what you need to do, but it's not a thing that we directly do a lot with, although on the roadmap when we talk about Linux in our future for EMS, DataSnap, and so on, then Apache web server will come into more play in there. But you can check out the developer skill sprints landing page and or the playlist on YouTube where Marco talks about how to use Apache on Windows, but he doesn't talk about the security things. I'm sure there's lots of resources out there about it.
Well, an example, I do know one thing about Apache is I do have it on a home server, and that is if you have an SSL key that has password protected, you need to actually physically type that key in when you are starting up the Apache server. There's not a way to configure that. And so that is a reboot issue. But it does make sure that it is secure. It's not stored anywhere.
Yeah, and I just want to mention,
except for RAM, obviously.
Yeah. Well, then they can listen to your memory. They can tap into your brain. No. I mentioned in the earlier introduction to encryption that Robert was talking about OpenSSL and all of that. In 10 Seattle, in EXE 8, EMS used the new native HTTP libraries, which we get from each of the platforms, so we don't have to deal with deploying OpenSSL.a files or DLLs or whatever. And in Red Studio and CBuilder and Delphi 10 Seattle, one of the new things we added was also using the native libraries, native HTTP client libraries that come with each of the platforms for DataSnap and for Cloud API.
And so like the TNet HTTP client component,
exactly.
This platform is easy.
Yeah, those you don't have to deploy anything else. You don't have to think. You just drop that component down, and you're good to go. It calls in through the operating system on each of the 4 platforms. For VCL on Windows, and then for FireMonkey on Windows, iOS, Android, and OS X. If you use Indy HTTP and TCP and so on, then you're still, HTTP. You're still tied to OpenSSL until there's an Indy update. Or if you have old projects and using older versions of our products, then just make sure you choose the right OpenSSL. When I was demoing before we released, when I was doing EXE 8 things, I needed to go to OpenSSL, grab the source code, use Xcode to create an iOS.a file that I could link with, for iOS 8 and iOS 9, that I could link with my Delphi apps that I was deploying using App Analytics and using DataSnap. So I still had to do that for EXE 8, and there's shell script files that you can download from OpenSSL in the source code to do that. I think it wasn't Project Indy. Maybe it was Project Indy. There was a site. We still have a link in our doc wiki for the older versions of our products where there was pre-built Windows OpenSSLs.
So
I never want
the binaries link that's on the screen right now will actually put you right to the Indy Fulcrum download.
Okay, all right. I always worried about getting a binary build of a security API thing, or linking library.
Yeah, you have to get it from a trusted source.
Exactly. Yep. Yeah. So that's a good link. It's if all you do is go out and search OpenSSL.dll or whatever, it's like, yeah, right.
So there's one thing I wanted to add.
Yeah.
And that is on this links and file session, the URL at the bottom. I know I recorded this demo with a Pascal example. I didn't have time to do both the C++ and demo Pascal recordings. However, on that download, there is a full C++ example of the exact same thing that I was demoing with Pascal. And so I know we're in the C++ side, and I wanted to make sure that that was clear so that people could really get a hold of what might be useful to them. And another thing that should be noted is EMS has, you can install as an Icehappy, which is really quite the simple and probably recommended way to deal with it. But if you do want to deal with it as a socket application, as a standalone application outside of Indy, it still does support SSL. Look in the EMS INI, and you'll be able to specify these security keys the same way that I demoed with the code, but you just have to specify them in the INI file, and they work.
Excellent tip. Yep. Ilya's asking how to use HMAC to avoid man-in-the-middle attack.
So an HMAC is actually is what internally like app tethering uses and a lot of REST uses, and the concept between an HMAC here is that it takes a key that is shared by both sides, and with that key you can hash the message that you're going to produce, and you get a new hash that requires that guarantees that the data was not changed in the middle, because both sides need the key. However, you got to be careful with that, because say you're writing a mobile application and you put that key right in your code, well then it's known, and you can still get exploited by a man in the middle. So an HMAC is only as good as the key that you use to secure it and making sure that that's secure. But once you have done that, so an example is we have internal applications here that communicate across to each other. In fact, they're using SSL, so I'm not even totally worried about that, but we do HMAC inside of that to guarantee that both sides are communicating, and since they're two systems that we own and control, we're able to ensure that there isn't a man in the middle that could deal with that data.